So an IP address is simply a unique identifier assigned to each device on a network. I will read that again. It is a unique identifier assigned to each device on a network. Okay, that means when they say it's unique, that means two devices on a particular network cannot have the same IP address. So every system have a unique IP address that's on a particular network. I don't know if this is clear. A system on two different networks can have the same IP address, but two systems on the same network cannot have the same IP address. They will not be able to communicate. It will cause what we call IP conflict. Okay, and IP address also enables communication between devices. Without an IP address, two systems will not be able to communicate within themselves. So that is one of the one of the things that IP address does. Okay, so we have two versions of IP address. IP addresses are in two versions. We have IP version 4, which is 32-bit. Okay, and we have IP version 6, which is like the recent version of IP, and it is 128-bit. So we're going to look at these two one after the other. Okay, the IP version 4 is the one that that most computers use. It is the one that is still trending. This IP version 6 is not really very rampant, though some devices are already using it, but it is not much in use like the IP version 4. Okay, so the IP version 4 is 32-bit. I believe we all know what bit is. That's like the smallest unit of data. So IP version 4 is 32-bit, and each of these this 32-bit is formatted into 4 decimal numbers. Okay, and is separated by a dot. Like for example, if you are looking at the screen, you will see there's an IP address. I wrote 192.168.1.1. So each of this segment is 88-bit. Okay, 8-bit is what is referred to as that's what they are called what they call octet. Okay, so it is divided into 4 decimal numbers separated by dot. Okay, then the IP version 6 is 128-bit. That means it is this one will be formatted into 16 decimal numbers, right? 8 decimal numbers rather, not 16. 8 decimal numbers, and each of the decimal numbers is a hexadecimal and separated by colon instead of dot, unlike the IP version 4. IP version 6 is separated by a colon, not dot. So we have types of IP addresses. Let's look at the type of IP addresses. I will share this material on the Google platform, so that, and yesterday's material as well. So we have type of IP addresses. So the first category of classification of type of IP addresses is the public versus private IP addresses. So there are IP addresses that are public, and there are IP addresses that are private. Okay, so the public IP addresses are used for devices that have direct access to the internet. They are used by devices that have direct access to the internet. Okay, and they are allocated by the Internet Assigned Number Authority. This is an organization that assigns IP addresses to devices. Okay, and every region have their own IANA. Every region have their own IANA. So for Africa, we have our own. If you go to US, they have their own IANA that is responsible for assigning public IP addresses to devices. Okay, then we have private addresses. This is reserved for internal networks, and it is not routable on the internet. That means it's not like the public address. Okay, so the classes of IP addresses that fall under the IP address, the private IP address, the class of IP address that falls under the private addresses are the class A, class B, and the class C. Okay, if you're looking at your screen, you see the range for each of these classes. So let's move order. So two, we have what we call, still talking about types of IP addresses. We have the static IP address and we have the dynamic IP address. Okay, so the static IP addresses are manually set and they are permanent. Okay, that means once you set it, it will remain like that until maybe you come and manually change it again. Okay, then we have the dynamic IPs, which are like they are assigned automatically once a computer connect to a particular network, if that network was programmed to assign IP addresses automatically using the dynamic IP. That's the dynamic host configuration protocol. It's a kind of a protocol that automatically assigns IP addresses to a device. Okay, so depending on the settings that you have done on your network, the IP address can either be manually assigned or automatically assigned using the DHCP. Like yesterday, from yesterday class, you will observe that I manually assigned the IP address to each of those computers. Okay, so we did not do the DHCP method. We did the assignment of IP addresses manually to each computer. Okay, then the next type of IP address that we have these special addresses. Okay, one is called the APIPA, or automatic private IP addressing. This APIPA is assigned, like, is a normally temporarily if a device fails to get an IP address from the DHCP. So this will assign temporarily so that that device will at least have an IP address to communicate before a normal IP address is assigned to it. Then we have the loopback IP address, which is within the range of 127.0.0.1. This is used for testing local machines network functions. Okay, then we have the broadcast IP address for communication to all devices on the network. Okay, so for a broadcast IP address, if you configure your network to use a broadcast IP address, that means any message that is sent on that network, all the system will receive it at the same time because it's broadcasting. Unlike when you are sending to a specific uh, IP address. Okay, so let's look at some IP version 4 address classes. Okay, so IP version 4 addresses are divided into 5 classes. We have the A, B, C, D, E. Okay, and this division is just to accommodate network of different sizes. Okay, so the class that you are using will depend on the size of your network. Okay, so if your network is just if your network is just a small network, then you go for like class C. If your network is medium, you go for class B. If your network is a large network, then you go for a class A uh, IP address uh, system. Okay, so the range for class A is from 1.0.0.0 to 126.0. So these are the range. When I send you the material, you can always look at it. All this stuff you don't really need to cram them in your head. As you're working with time, you will understand which range a particular IP address falls in. Like if you look at our network that we were trying to configure yesterday, we used a class C IP address which started with what? 192. Okay, so if you see an IP address that is starting with 192, not minding whatever other values follow it, just know that it is a class C IP address. Okay, then we have class D. The class D IP addresses are reserved for multicasting, which is what we just saw in the previous slide. Then we have class E. This one is reserved for experimental purposes, people that want to do research and experiment. So this class E, this range 240 dot whatever value follows it, is reserved for experimental purposes. Somebody is saying I can't hear anything. Can you all hear me? If you cannot hear me, please indicate in the chat box. Let me know if you can hear me or not. Okay, so let's look at structure of okay, I can hear, that's fine. So let's carry on. Structure of IP version 4 addresses. Like I earlier said, IP version 4 is a 32-bit IP address, and it is split into 4 octets. Okay, for those of you that did mathematics, you know when they talk about an octet, they are talking about 8. Okay, when they talk about octet, is 8. So it is split into 4 octets. That's 8 bit each. That means each of the octet is 8 bit, 8 bit, 8 bit. Okay, and like I said, bit is the smallest unit of data. Okay, so the way IP addresses are represented is that each octet is a decimal value between 0 and 255. Each octet, okay, that is in between all these places where you have your dot, and dot and dot. Each of those octet ranges from what 0 and 255. Okay, for example, if you're looking at your screen, you see 192.168.1.1. so each of these is representing an octet. Now if you convert this 192.168.1.1 into binary number, this is what you'll be having. This one you're having 110000. You see an 8-bit number, then a dot, another 8-bit number, dot, another 8-bit number, dot. Okay, so that is the when you convert it from decimal to binary. That's what the computer really actually understands, that binary number. So whenever you input your IP address, the computer will convert it into this before it can read and understand what you are talking about. Okay, so each IP address, that's this 4 octet that we're talking about, is made up of 2 components. Each IP address, okay, we have already established that IP version 4 address is split into 4 octet. Now each IP address is divided into what? 2 components. One component of the IP address, that's the first component, is usually represent the network. It identifies the network, while the remaining component identifies the device within the network. Okay, let me break this down in such a way that you can understand. Okay, in this situation, what they are referring to as the network is like, let's liken it to a family. Okay, let's say you have a family now. Let's say you have a family. Let's say you have a family like Ugochukwu Nwafo. Okay, now your own name might be Ugochukwu, and your surname is Nwafo. Okay, your family is the network. Okay, that your family name identifies what? The network. This is just an example I'm trying to give so that you understand. Then the host represents you as an individual. So you now, you are like a computer within that network. Okay, so this host represents a particular computer within an entire network. So a part of your IP address represents the network, while another part of your IP address represents the you as an individual. That's a computer. Each computer is a host. Okay, identifies the device within the network. I don't know if this is clear. If you understand what I'm saying, just type yes in the comment section so that I'll know we're moving together, because this can be a little bit tricky. Okay, so Inone understands, Abdul Salam understands, Kingsley understands. So we're still talking about structure of IP version 4 addresses, and we're still talking about the component of the IP address, which is what? Network and the host. Okay, so the logical 32-bit IP version 4 address is hierarchical and is made up of 2 parts, the network and the host. This is what I just finished explaining. Both parts are required in an IP version 4 address. Okay, both your surname and your own name that was given to you is required for you to function as a member of your family. It is your surname that will make them to know that you are from this family. Okay, The same way it is the IP, the network aspect of your IP that will make them know you belong to this network. Okay, then the host aspect will now identify you as an individual in that network. So both networks have the subnet max 255.255.255.0. okay, so we'll talk about this, what subnet max is, maybe as we continue. We'll talk about what a subnet max is. Okay, so both networks have the subnet max 255.255.255.0. The subnet max is used to identify the network on which the host is connected. Okay, so if your subnet max is 255.255.255.0, that means the first 3 octets. Are you following? I already explained what octet is. The first 3 octets represent your network, while the last octet, which is this 0, represent the host. I'll come again. If your subnet max is 255.255.255.0, that tells you that the first 3 octets represent your network, and the last octet, which is the 0, represent your host. In other situations, you might have something like 255.255.0.0. That means the first 2 octets represent the network, and the last 2 octets represent the host. I don't know if this is clear. As an example, it's like I'm jumping something. Okay, the subnet max is used to identify the network on which the host is connected. As an example, there is a host with an IP address 192.168.5.11 with a subnet max of 255.255.255.0. Don't worry, we'll explain what subnet max is shortly. Okay, the first 3 octets, just like I said, the first 3 octets in this IP address now will be what? 192.168.5 identifies the network portion of the IP address, and the last octet, which is 11, identifies the host. Please, this information is very, very important, especially when you'll be going into proper cybersecurity. Okay, you need to identify which part of your IP address represents the network and which part of the IP address represents the host. Okay, this is known as hierarchical addressing because the network portion indicates the network on which each unique host address is located. Routers only need to know how to reach each network rather than needing to know the location of each individual host. Okay, so when a router is looking for a network, what it does is a search for the network aspect of the IP address. Nothing concerns the router with what the last aspect is, the host aspect is. That's the individual host. Okay, with IP version 4 addressing, multiple logical networks can exist on one physical network if the network portion of the logical network host address is different. For example, 3 hosts on a single physical local network have the same network portion of their IP address 192.168.18, and 3 other hosts have different network portions of their IP version IPv4 addresses as 192.168.5. The host with the same network number in their IP version 4 addresses will be able to communicate. Okay? So it is that your surname, okay? It is that surname that is the network aspect of the IP address. Let's say there's a particular way you people communicate in your family. Okay, somebody that does not have this particular network address may not understand what you people are saying, and if you send a message, it will not reach the person. I don't know if you are still following or I've lost you. Okay, in this example, there is one physical network and two logical IP version 4 networks. Another example of hierarchical network is the telephone system. With a telephone number, the country code, area code, and exchange represent the network address, and remaining digit represent a logical phone number. So they are just trying to give you trying to explain this in another way using your phone number. Okay, if you look at phone numbers, you discover that the first numbers on your phone, the first I think the first 3 or first 2 numbers usually represent the country code. Like for Nigeria now, we have +234. If you go to other countries, it might just be +1 2 or +3 +9. So that represents their own country code. Okay, so if you want to call a particular country, you have to know what is the what first number represents the country code. Like somebody that is outside Nigeria now, if they dial your number and they did not put the country code, they will not be able to reach you. If maybe they just dial 080 this that, they will not be able to reach you if they did not put that +234, because they are not within the same country as you. So let's study this diagram. So if you look at this diagram, these are two networks. Okay, one network is to the left, another network is to the right. Now if you look at all the IP address on the network to the all the IP address on the network to the left, they all have the first 3 octets are the same. I'll come again. If you look at the IP address that are on the network to the left, the first 3 octets are the same, which represent the network number. Then the difference is now just on the last octet, where you have 99, 11, 22, 33. So these last numbers now is representing each computer. That's the host. Okay, so those last number are identifying the host, while the first 3 octets is identifying the network. The same thing if you come to the other network to the right, you see that all the in all the IP addresses, the first 3 octets, the numbers are the same. It's only the last number that represents the host that is changing. Okay, if you understand, please just type understand in the comment section, then we can continue. I know this can be a little bit complicated. Okay, God's gift, understand. Fumilola, understand. Understand. So So let's move further. I'm glad you are catching up. So now let's look at subnetting. Okay. When we talk about subnet, is just like a short form for having sub networks. Okay, that's like breaking down the network, breaking it down so that you can create more networks out of a particular network. That's what subnetting simply means. Okay, subnetting is the process of dividing a larger network into smaller sub networks. So when you hear of subnet, it is short form for sub networks. Okay, and the purpose of doing this is usually so that you can have efficient use of IP address space. You can improve the network performance and security. You can isolate network segment for better management. Okay. Subnet max defines the division of network and host, the network and host portion of an address. Okay, so it is through the subnet max that you will know which portion of the IP address is the network and which portion of the IP address is the host. I come again. It is the subnet max that will let you know which portion of the IP address is the network and which portion of the IP address represents the host. For example, again, we have 255.255.255.0. Whenever you see a subnet max like this, the first three octet, that is 255.255.255, represent the network, while the 0 at the back represent the host. Okay, so there's something that is called classless interdomain routing, CIDR. Sorry for the disruption. So like I was saying, this CIDR, that's classless interdomain routing, instead of writing this long subnet of 255.255.255.0, what they do, after writing the IP address, you just put a slash and then you put a number behind that slash. So it is that number that will now tell you the subnet of that IP address. That will also tell you which portion of that IP address represents the network and which portion represents the host. So for the example you're seeing on the screen, we have 192.168.1.0/24. Okay, that means the first three octets represent the network address, because 24 is equal to 3 octet. That's 888. 8-bit, 8-bit, 8-bit into 3 places. I don't know if that is clear. If you see 16, if you see /192.168.1.0/16, that means the first 2 octet represent the network, while the remaining octet represent the host. If you understand this, please type I understand in the comment section. Let me know if I'm making sense. So in some situations you might see /32. That means the entire IP address represents the network. Okay, so what are some of the challenges with IP version 4? IP version 4 have some challenges. One is address exhaustion. That means they use all the available, like all the available IP addresses under IP version 4 are getting used already. Okay, so that was a big challenge. That is why they had to introduce IP version 6. Okay, so the 32-bit address space limit the number of available IPs. I know the internet is growing every day. Growth of the internet connected devices has accelerated. Okay, so every day internet is growing. In fact, every day they are creating new computers, new phones, new devices, like almost every day. So this IP version 4 is getting exhausted already. Like at some point there may be no more available IP addresses to assign to devices again. That is why they came up with the IP version 6, which is 128 bit. Okay, then another challenge is network address translation. Okay, if you follow the class from the beginning, there was a place where I talked about types of IP addresses, and I was talking about public versus private IP addresses. Now the challenge is, if you want to send something, if you want to send data from a private IP address to a system that is using public IP address, that means your IP address will have to be converted to a public IP address using what? This NAT, network address translation, so that other IP address, which is a public IP address, will be able to read what you are sending. Okay, and vice versa. If you are sending something from a public to private, it will have to convert so that your address, your own private IP address, can also read what it is sending. So that is like a challenge. That's one of the challenges with IP version 4, and that was taken care of in IP version 6. Okay, then number 3 challenge is security concerns. Okay, like IP version 4 doesn't come with like it doesn't have, in Nigeria we call it follow come. It doesn't have follow come encryption. Encryption is like making something unreadable or to somebody that is not supposed to read it. Okay, it lacks native encryption and authentication. So if you want to secure your IP address, there's a protocol that is called IPsec, which is short form for IP security, that you have to use in order to secure your IP address. That's why you see hackers or scammers and whatever you call them, if they want to access the internet, most of them use what we call VPN. Okay, they use what we call VPN. What VPN does is it can hide your IP address, it can even hide your location. You can see somebody that is in Nigeria browsing, the person can change his or her location to maybe United States. So if you were to track the person, your tracking, you will be tracing the person back to United States instead of Nigeria. So these are concerns in IP version 4. These are some of the challenges that IP version 4 had, and that is why they had to introduce IP version 6. Okay, so the advantage of IP version 6 is that it has one larger address space. Okay, IP version 6 has about 2 raised to 128 addresses, providing ample room for all devices. So no, maybe in the next let's say I don't know how many years, before this can get exhausted, it will take a very long time before they start thinking of building uh, or coming up with another version of IP address, maybe IP version 8 by then or IP version 10. It will take a very long time. By then, most of us might not even be existing again, because this is very large. IP version 6, it comes with built-in security, unlike IP version 4 that does not come with, it doesn't have follow-come security. IP version 6 has a built-in security, okay, for secure communications. IP version 4 is efficient, very, very efficient. Like, it doesn't, when it comes to routing, IP version 6 is more efficient than the IP version 4. So what are the types of IP version 6? We have the unicast. Okay, when we talk about unicast, that means just like a one-on-one communication. You are sending message to this person and the person is replying. Two of you are communicating. No other person can see what you are doing. Multicast allows you to send to multiple devices. So then we have anycast, route traffic to the nearest device in a group, commonly used for load balancing. So when you send something, it looks for the nearest device and drop the stuff. Then that device will also look for the nearest device and drop. So it will move like that until it gets to where you are supposed to send it. Multicast sends to every device on the network. Unicast sends to a particular device. So these are the three types of IP version 6 addresses. So routing. I think somebody was asking this question yesterday about when I was saying wireless access point, that's WAP, does not do routing. The person was like kind of, I think it was Abdullah Raji that was asking that question, that I should explain how that wireless access point does not do routing. Okay, so routing is the process of moving packet across different networks from the source to destination. So normally when we talk about communication, whether you are speaking to somebody or however you're communicating, there's always a source and there's always a destination. Okay, so what routing does is it looks for the best possible way that your data can move from the source to the destination where it is supposed to reach. And we have types of routing. We have static routing. This is where you manually configure the route, best for small or simple networks. Okay, so you configure the route that the packet will take manually. Then we also have the dynamic routing, which automatically adjusts route based on network changes. It looks for the best route by itself and automatically send your packet. Okay, so we also have routing protocols. We have distant vector protocols. Okay, and what distant vector protocols, DVP, does is it routes data based on distance metrics. So it looks for the nearest or the shortest possible route. And some of the protocols that are used here are RIP, EIGRP. Please, this RIP is not, it doesn't stand for rest in peace. Okay? You can go and find out the meaning. But it's not rest in peace. If you know it, just type it in the chat box. so that we know that you know it. RIP. It is a routing protocol. It's a routing protocol. Okay. It's a distance vector routing protocol. Distance vector protocol. Nobody is dropping the answer, so nobody knows this. Okay, let's continue. We have link state. We have link state protocols. So this uses topology of the entire network to calculate the best path. You know, when we started with networks, I talked about network topology, where we have the star, the ring, the bus, and all of that. Routing information protocol, yes, that's the answer. Fumilayo. Okay, it's Rukewe. That was Rukewe first typed it, so that's the answer. So we have link state protocol. Link state uses topology of the entire network to calculate the best path. Okay. So some of the protocols that are used here is OSPF. Then we have ISIS. You can find out the meaning of all of these terms. So let's look at routing tables. Routing tables. Okay. A routing table is a data table stored in a router or networked computer that lists the route to a particular network destination. Now, this is what usually happens when you connect a network. Okay, let's say you set up a network, and on that network there are like 20 computers, and these 20 computers, they have not communicated with each other before. You understand? You know, when you have a network, you're going to have your router, you have switch, then maybe you might have another computer that is serving as a server. Okay, so now when you set up your network for the first time, this network, they don't know each other. It's just like they don't know, let's say they don't know each other's IP addresses, they don't know each other's name, because they have not communicated before. So with time, when you begin to send information, to a particular network, maybe PC1 communicate with PC9, the router will now store the information that they use in communicating. That's what they now call the routing table. It will keep that information for the future. Okay, so when you are sending for the first time, and because those information are not yet on the routing table, the router will have to, it might take more time, because it will have to search each computer one after the other to look for the particular IP address, that's the destination IP address where you wanted to send the information to. So the information on the router will be the source IP address, which is PC1, and the destination IP address, which is PC9. So when it has searched around and located who is PC1 and who is PC9, it will store it on its memory. So this is what they call the routing table. So next time, if PC1 wants to communicate with PC9, it's easier for the router to push the data immediately, forward the packet immediately, without having to now start doing calculation again. So the same thing happens to other PCs. As they are communicating with time, the routing table will keep populating. It will keep adding all their IP addresses on the routing table until it has all the addresses of everybody, so that if this person send data, you will just know, okay, this data came from this person, the source IP address is this person, you forward it to that person. If this one sent, so that is what they call the routing table. It's a data, it's a data table stored in a router or network computer that lists the route to a particular network destination. Okay, so what are the contents of a routing table? We have the destination, the network or the IP address to reach. Then we have the next hop, the next router or IP to forward the packet to, of the metric, the cost or priority of the route. So that's the best route to take to reach the destination. So a lower matrix is usually preferred. Okay, so we have route types. We have directly connected route. That's route within the router's own network. You understand? You know, if you have a particular network within your office and they are using just one router and you want to send information just within that network, it is a different situation entirely. That's what they are referring to as a direct connected route within the router's own network. But if you now want to send something from your office to another location outside your office, that information will go to the router. Your router will now communicate with the router of that other office. Then the router of that office will now look for the IP address on its own network and send the information to. Okay, so we have the remote route to network outside the router's immediate network. Okay, let's look at default gateway. You know, when they say something is default, okay, default gateway is the IP address of the router that routes traffic to other networks or the internet. Okay, that's the, if you look at our configuration yesterday, when we started by configuring the router, so those IP address that we put on each port of the router is what they are referring to as the default gateway. Okay, that means before you get into that network, before you reach any of those computers from outside, you have to pass through the default gateway. Okay, it acts, the purpose of default gateway acts as the exit door from a local network, allowing traffic to reach external network. Okay, often provided automatically by DHCP, or you can input it manually. Yesterday we did it manually, not DHCP. Then we have static versus dynamic routing. I think we have discussed this somewhere. Static means manual, something that is manual. Okay, and the disadvantage of having a static routing is that it doesn't adapt to network changes. So if over time the network changes, you have to come and manually make your own changes. But for a dynamic routing, if network changes, it will change with it. Okay, the disadvantage of static the advantage of static routing is that it is simple to set up and it is predictable. Meanwhile, the advantage of having dynamic routing is that it is efficient and reduces administrative burden. Disadvantage of dynamic routing can be more complex to configure. That's for dynamic routing. It is more complex to configure. So with that, I think we have come to the end of today's lesson. This is 8:32.